Here in problem 1, we're told that the odds for an event E to occur are 8 to 5, and we're asked to convert that to a probability. So here's what we do know. In general, we know this, that if the odds are A to B, then the probability of that event is A over A plus B. So the odds are A to B, so the first number goes in the numerator, and the denominator is the sum of the two. So what we're given here is that the odds are 8 to 5, so if we write this as 8 to 5, we're going to say that the probability of E then is 8 over 8 plus 5, or 8 over 13. And in number 2, this was just the opposite of number 1. Now here we're given that the probability is 7/12, and we want to convert this to odds. So we're going to use this formula right back here. If we're given the probability converted to odds just going this way, that says that, all right, here's what we know. The probability of E is 7/12, but look over here at this denominator. The denominator, if we can break this apart into the sum of two numbers, take the 12, break it apart into something plus something, where, you see that? The first number here matches the number on top. So what we're going to do is we're going to break the 12 into two numbers, one of which matches the top number, right? See this definition over here? Those two match. So we're going to get 7 over 7 plus 5. And that means that the odds for E are 7 to 5. In 3, Joe feels the probability of getting an A in history. You know what? Let me write this stuff down so I can kind of summarize it. The probability of getting an A in history, Joe thinks, is 0.6. The probability of getting an A in, what do we have, psychology here, is 0.8, and the probability of getting an A in history or, right, union, or psychology is 0.9. And what we want to know is, what's the probability he will get an A in both? Now, both we can write like this. What we're trying to do is this. We want to find the probability of getting an A in history and an A in psychology. Well, look at what we have. We have this individual, the union, and the intersection. We just happen to have a formula that has all that stuff in it, which is this. The probability of H union P is equal to the probability of H plus the probability of P minus the probability of the intersection of those two. Let's just fill in our numbers. This is 0.9 equals 0.6 plus 0.8 minus the one that we're looking for, H intersect P. And this will give us 0.9 equals, now these two together give us 1.4 minus the probability of H intersect P. You know what? Let's just subtract that. So we'll get negative 0.5 is equal to negative the probability of H intersect P, giving us that the probability of H and P both getting an A in history and psychology is positive 0.5.